Welcome to the fifth IR community hosted by Multi-Cloud for You. Hello everyone, a very warm welcome to all of you. I'm Suchi Mishra, your host for today's event with my co-host Lavik. So today's session is all about building production-ready AI apps and with Llama, Hugging Face and Python, presented by Dr. Abhishek Mishra. So before begin, let's take a moment who we are and where we're standing for.
First, we have to understand what we do, who are we. So talking about fifth IR, so fifth IR is a stand for Fifth Industrial Revolution, and fifth IR is a single stand learning community and a platform where you can learn, grow, and polish your skill. So as you can see, we started 5 years back in 2019. Then we grow and recognized by big names. Then we expand our horizon, and in 2022 we convert a single stand learning community to a platform, and then we create events, give mentorship, and so many things. Talking about the fifth IR features, so for users, the platform help people create different type of profiles to market them better. You can create your business card, and talking about business card, you can create your digital visiting card. You can go to the fifthir.com and create your digital V card. And we are very soon going to launch NFC card also. So you can check out on fifthir.com. And yeah, back to slide. You can create your CV, company page, business page, mentor profile, and talking about professional, you can enhance your business and product also. And for the organization, you can create a community, you can give a mentorship, create a blog, give quizzes, conference, event, job conference, job post, speaker profile, quiz, and so many things. And talking about Multi-Cloud for You, so Multi-Cloud for You is a community-focused tech firm building data platform and custom products with consulting and engineering. We work on generative AI, blockchain, data products, data platform, cloud, and talking about domains. So we also work in retail, banking and finance, energy, healthcare, IT, and we have so many clients supported across the globe, such that America, Latin America, Europe, Middle East, India, Oceania. So we are not talking in here. Here are numbers justify our growth. So we have 31,555 members on registered on fifth IR and Multi-Cloud for You, and we distribute 8,880 certificates across the globe. We have 413 speakers, 23 courses, 275 sessions, and so we also run a reward certification program, and we give a certificate to our top speakers. And we are also a partnership with Alibaba Cloud Academy. So you can go to the fifthir.com and enroll in any courses you are interested in, and you will get this Alibaba Cloud certificate. And so by the end of this session, you will get a link in your team chatbot. So by clicking on that link, you have to give the quiz, and after completing the quiz, you will get the certificate from us. Talking about a speaker, Dr. Abhishek Mishra. Dr. Abhishek Mishra is a seasoned cloud architect with over 20 years of industry experience in driving digital transformation through cloud and AI, and early adopter of Microsoft Azure since 2013. He has led enterprise grade cloud initiative worldwide. And Dr. Mishra is also a TOGAF 9.2 Microsoft certified Azure solution architect expert and an AI engineer. So it's time to call his speaker, Dr. Abhishek Mishra. Dr. Abhishek Mishra, over to you.
So thank you, Fifth IR, for this wonderful opportunity again to speak at this wonderful forum. I love speaking at Fifth IR. So today I bring you a very exciting topic, like a very much of a futuristic topic on how to build intelligent apps using Meta Llama via Hugging Face API inference. So when I talk about Hugging Face, it's a open source hub where you can find a lot of models around there. You can download those models even locally, and you can work on those models. And the best part is you can also work using API inference. You need not, if you don't want to run or download the models locally and work on it, absolutely fine. So you can also use the API inference way, like we do it for ChatGPT or OpenAPI AI or Azure OpenAI or any of the popular PaaS services. And I would say like this is the best way to like experiment and try out the models before you adopt those models to any project. So normally when you think of building a GenAI application or you are a GenAI architect, the very first thing you do is like you select the right model that will fit to your use case. And this is the playground where you can try these models and have a flavor of it, and then you can actually try. Like it's there's more lot to it. Maybe when I dive into the session, like I progress through the session, I will be able to show you. Okay. So anyways, like thanks for the wonderful introduction. So I will just skip this about me, and I will directly focus on the topics that I have in my agenda. So like today we will start with the basics of AI MLDL. What I mean by that, actually, sorry for the acronyms. Like it was, I would have definitely loved to expanded them, but uh, like somehow I ended up writing those acronyms. AI is nothing but artificial intelligence. ML is machine learning, and DL is deep learning. Okay. So why I'm not directly jumping into the topic is because I want to build some fundamentals. Okay, so there can be the audience who are very new to the AI world or the generative AI world, and it's important for them to understand the evolution before I jump into Hugging Face. Okay, so let's start with the very first thing that is artificial intelligence. But before I define AI, can someone from the group tell me like when was the first AI application built, or when did AI started? Any guesses? Okay, let me tell. So it all started in 1950s. Okay, so in 1950s the AI started, and it's a very wide domain actually when you talk about AI. Okay, so in 1950s, so we had some rules. So based on the rules, like we used to like build our AI applications. Okay, so this is your AI. So we at that point of time in 1950, so we had a lot of rule-based applications, like if this happens then this or that, and slowly AI graduated into like something called as subset called as machine learning. Okay, it's a subset of AI where like we brought in concepts like probabilities, statistics. Okay, the models started use like we started talking about models who could work on statistics and all these things like probabilities, and then came up those concepts of like supervised learnings, unsupervised learnings, then uh, so where like we normally label the data, and we know the features definitely. Like when I say features, like suppose any artificial intelligence program, or any ML based programs, they work on a feature identifications. We need to identify the feature and tell like maybe like the age. Like suppose you are doing a survey of like the age of maybe the income spent across various age categories. So you need to identify people on age, then gender and all. So these are nothing but these are the features. Okay, and then you label the data. Okay, do some data labeling, and then like on the label data, like your supervised learning will run. Then we had the unsupervised uh, learnings were happening, where like part of them is labeled and part of them is not labeled. Then you have sorry, it's the semi-supervised learning where you have the part of the data set is labeled and part of it is not labeled. And then like you have your reinforcement learning, like where like you have like you penalize your the model if they do the right thing, and if they don't predict the right thing, then you penalize it if you they do not do the right thing, and you don't penalize it then when like they're doing the right thing, you reward them. Okay, so this kind of models came in. You also had the unsupervised learning, like that didn't have any labels, but feature was the key. So you need to identify the feature. Then this was the era of your machine learning that was based on statistics, and where like you had the supervised learnings, unsupervised, and reinforcement learnings. Then came the era like of deep learning, where what you did was like uh, these applications started thinking just like human brains. So they mimic the human brains. So what is a human brain? Human brain is nothing but it has a lot of nodes called as neurons. It's a combination of lot of neurons, and those neurons like they talk to each other and take a decision. In the same way here, so how these models, deep learning models work is they have a bunch of neurons. Okay, so maybe or nodes. Okay, so these are the nodes, for example. So I'll just put some nodes. Okay. Okay, so these nodes will communicate with each other. Okay, then they will also communicate among themselves. Okay, then uh, so these all these nodes, I'm just showing here some 5 to 6, but there are millions of nodes which communicate among each other and take a decision. And all each there is something called as weights associated to the learning parameters. Like for example, a nodes is processing some kind of information. That information is multiplied by that weight, and that multiplication results whether the next node should activate or not. If it finds that this node should be activated and the weight is unable to activate it, then it will go back, it will propagate, do a backward propagation, and it will adjust the weight and make sure that the weight is adjusted so that this next node is propagated. So this is how the things move back and forth, and nodes get activated, and we get the results. So it has an input layer and output layer, and like a lot of hidden layers in between. So these all are the hidden layers of the neurons. This is how like the neural network works. So that was all fine with neural networks. Like we had our something called as recurrent neural network that processes the information sequentially. That means when I say that I have a dog at my house, so it will first process I, then have, then then dog, then at my house. So each of these information will flow sequentially among the nodes. They will be processed one by one. So that adds to a delay and also brings in a problem like where like the model needs to remember the context of longer strings and or what has happened long before. So to overcome all these complexities, there is something called as a transformer that came into existence. And what those transformers did was, so those transformers are clever enough, or they use something called a self-attention, where they are able to process like each of these letters or words in parallel. So when I say I am a boy, or like I have a dog at my home, so the entire sentence, each word of the sentence is processed in parallel instead of processing it sequentially using this RNN or this recurrent neural network. So that is how the transformers came out. And transformers are ones that you see in the chat GPTs or like Gemini BERT, the BERT models with Google Gemini that helps you in text classifications and all. Those, or rather the text generations and all. So this text generation mechanisms, they came from these transformers. Okay, so now like with the transformers, we started like generating tons and tons of text, and it was all working good. Then it evolved to something into a new area, like where like we need to generate videos and images. So then the researchers then they came back with different kinds of models. Maybe you must have heard about deep fake, the deep fake applications. Like they're based on GAN, something called as GAN model, or generative adversarial network models. And what they do is they have two sets of neural networks. Like similar to this, they have two sets of neural networks. One of the neural networks will be creating or generating the images. The second neural network will be saying that whatever the first neural network is generating is fake. Then the first neural network will take the feedback and will try to improve on it. And again, the second network will try to prove it as fake. So as a result, with the competition between both the neural networks, you finally end up with having a very good image quality, and it's able to fake an image really well. So that is how the generative generative adversarial network works. And also, like, there is one more kind of image generation models called as diffusion based models. What it does is if you give these models an image, it will keep adding noise to it. And once a lot of noise is added, the image gets distorted. Now from this distorted image, the generative AI model will be very innovative in removing the noise and transforming the images to a lot of possibilities. It's just like I give you a block of marble and I'll ask you to carve it out from there. So you will use your creativity to shape that marble into the right the right statue. Okay. So you get the raw block, and from the raw block you craft the things. The same way, from the image we add noise and make it as a raw block, so that imagination can be applied and the images can be created based on the algorithms. So this is how generative AI has come into existence today, and this is the whole journey of how the things have worked. So with this background, now let me take you back to my slide. I know I was a bit fast, but don't worry. If you have also not got the concepts what I wanted to communicate, it's absolutely fine, because I will be it's not needed to follow what I'm going to demo today. But again, knowing these models, knowing this evolution is important, because as an architect, when you are going to design your application or generative AI application, you need to know which model to choose, what is happening in the background. So all these informations will help you. Okay. So let's get started with this prerequisites that I just briefed you. So artificial intelligence is nothing but it's a field, or where machines start thinking like humans. And there are various applications, need not say, all of us are aware, we have natural language processing, visions, robotics, recommendations engines, lot more. And the very key idea is enabling machines to mimic human intelligence. Okay. So I just spoke about the machine learning, it's a subset of AI, where that uses a probability and statistics. Okay. That uses probability and statistics to do supervised, unsupervised, and the reinforcement learning. So reinforcement learning is nothing but it works on a penalty system. If the model doesn't predict something right, it is penalized. If it predicts okay, then it is rewarded. Then again, if you don't label the data, then it is unsupervised. We also have a semi-supervised, then part of the data is labeled and part is not labeled. And a few of the example is spam detection and recommendation systems. Hey, just 1 minute, I'll just verify thing. Okay, sorry, apologies. I had turned off the video feed. I've turned it on. Okay. So then then I have already explained you what deep learning is. So with deep learning, what we do is we try to think like a human brain. Brain is nothing but a bunch of neurons. So in the same way, we build nodes for our like for our models, in our models, so that like each node is a neuron and can think like a neuron. We have millions of those neurons mimicking the human brain. And this is the point where generative AI started evolving. And one of the most important feature to highlight is feature extraction. So in semi-supervised, or rather like in machine learning, you provide the feature, but here like it's intelligent enough to unlock the feature for you. Okay. So next, I have already spoken about neural network. I'll how it works. It has three layers: input, hidden, and output layers. Like basically, each of these layers is nothing but this bunch of neurons or the nodes that we see here. And the data flows to and fro. Like for example, like I told you, like each of these inputs are multiplied by weights, and the output is generated. If the output is like sufficient, then there is something called as activation function, for which the other neuron, the next neuron in the queue, that gets activated. If it is not, and if it should have been activated, then a feedback goes back to the previous input, and then weight is adjusted, and again the data flows into the next node. And this is how the data goes to and forth, making sure that the neurons keep activating, and your network, your input gets processed. Then I spoke about, already I have demonstrated you, or rather I spoke about the recurrent neural network that handles the information sequentially. Okay, so the very problem I told you is keeping the context, because if the sentence is long or in paragraphs, it struggles to, or it needs a lot of memory to keep the context. So that is why where we came up with these large language models trained on transformers. So these transformers are nothing but they are a set of they just not understand the natural language. They do much beyond that. So what happens exactly is you must, if you have worked on ML applications back in 2016 or 2017, that is the time when I started on AI and ML, on Azure Machine Learning Studio. So there we used to, for NLP, we had a concept of we used to actually, like for example, I say I am a boy, then we have a unigram, I, that's a single word. Okay, we had bigrams, like I am, like two words, it's a bigram. Or we used to have a multigram, or n-gram. Basically they're called as n-grams, where it is a it's a combination of a lot of words, and using those grams, a prediction used to happen. Like for example, I say that I am a, so based on that, if I'm using an n-gram concept and I am a is 1 n-gram, then after I am a, the model will predict that I am a boy. Like for example, you are using a unigram, I love eating. So eating can be based on that word eating. It is considered as a unigram, and for that eating, a lot of words will get predicted. So that is how your NLP used to work in those days. If you worked on NLTK and all, natural language toolkit and all, this is how it used to work. But in LLMs, they don't work that way. So they use transformers. Let me see if I have a, yeah, I have a transformer. So they have a encoder decoder mechanism. They use something called as an attention, self-attention mechanism, where like when I say I am a boy, then I am a boy, all these words are processed in parallel, and like they're positionally encoded. That means they will it's not just about um, predicting. It does a semantic like it understands the context. Basically it does a semantic search, definitely, like it understands the context. Okay, by doing a positional encoding based on, like, say I say that I am a boy, then is kept in a is assigned a position in the sentence. Boy is defined a position in the sentence. For example, someone says or it's like boy is relatively near to A and far from I. So based on those information, it does the prediction, and this makes sure that the context is preserved, the real context of the sentence. Like, for example, there is a sarcasm, like someone posts that I had a great flight, but I lost my baggage. Thanks for the great flight, I lost my baggage. If you give this to flight, a natural language processing will not work here. NLP, normal NLP will say that the sentiment is bad. But if you're using a transformer, so it has the capability of understanding it the right way, that the it's not a positive sentence, it's a negative one, and it should not be that way. So that can only happen because of this context handling features or using the positional encoding. Okay, so lots of theory. Now let's get to Hugging Face. I will take you to Hugging Face and I will show you some few of the things here. Okay, so before I get into the Hugging Face, so let me tell you what Hugging Face is. Hugging Face is an open source hub. Okay, so you'll find a lot of data sets. You'll find models, open source models, or they call it open weight models. When I say open weighted models, so you can download these models. I spoke about weights, right, in neural networks. So when the data flows through the neural networks, it gets amplified by those weights. If the next activation function doesn't activate the next node, then this weight is adjusted through a feedback mechanism. Okay, so you can download these models and you can actually adjust those weights. Okay, the weights are exposed to you. That's why they are called as open weighted models. And you can also build your application and put it there. Okay, and you can use those URLs for inferring those models. And it's a community driven ecosystem. I'll just show you to you. Okay, so before I get into the Meta Llama thing, let me take you to the Hugging Face interface. Okay, this is your Hugging Face. Okay, I have already created a user ID. You can create a user ID and log in to the Hugging Face. And here you can see various models listed here. Okay. So you can use these models. You can download these models and run it locally. There is a package called as transformers. So you can use those transformers Python package, bring down these models to your laptop. These are lightweight models and you can run them on your laptop. Okay. So if not, you can also do it the way we work on our with our Azure OpenAI or any OpenAI applications by using those URLs and the keys. I'll show you how to generate the keys to work on them. Okay. And also it's a community driven one. You can write your own blogs. You can post in blogs on Hugging Face. You can interact with other fellow researchers or developers who are uploading these models. Okay, and you can if you need a data set, like you want to have a data set to build your Python model or sorry, your generative AI model, your own generative AI model, or you want to use those data set for something, you can download it from here. It's a lot of community driven data sets that you can find, and they're really useful if you're planning to build your own model or you want to use it some way. Then the best part is Spaces, where the developers, they build their own applications and they have hosted it here. You can come and suppose you want to use use their model, you can come here, you can check that model and you can use it. Like for example, what I'll do is I will just go to this Quen image. I'll just go to image generation. Okay, I'll just take this Quen image. No, not control net. Queen image. Yeah, it's a simple one. Okay, I have already logged in to do the inference. So maybe I can say something like generate a, a happy cat for me. Drinking Coca-Cola under the sun. Okay, then let me submit it. So it takes a while to process it. Just hold on, like it takes a while. Meanwhile, I'll show you one more while it's happening. Even like there is something called as a Queen image application that someone has built. So maybe like I like this animal capybara. So let's try this. Oh, okay. I think there is some issue. Okay, let's see. Maybe I'm trying to do two things simultaneously. Got that error, but that's fine. Let it generate. Um, okay, so it generated this capybara for me, and I know that I see that it's a good image generator. So what I can do is I can actually go to download the model and I can use the model. Okay, so that is how I can actually go ahead with this. So this one, I think it's still generating. It will take some time because normally these models that take time. So I'll just close this. Okay, so you can actually how you can use this platform is you can build your own application, your own models, host it, and also build some applications, and you can actually demonstrate those applications on this model. Community can see this, they can consume it. And when I talk about models, one moment. Okay, so when I talk about models, there are plenty of models. You can consume them. Okay, now let me go back to my presentation about Llama. Okay, Llama is developed by Facebook AI Research. Then it's an open weight LLM for sure. I have already explained you what open weight LLM is and can be definitely used for research as well as commercial use. There are variants like Llama 2, Llama 3, like fine-tuned versions. There are different versions of it. Like we have a GPT-2, GPT-3, same way like Llama has also evolved. And mainly the use cases are chatbots, summarization, coding, all this. The text-based stuff work great. Like they're intended to do that. And like why inference API is important for Hugging Face, because if you're using Hugging Face, so like one way is you can definitely you can use the transformers NuGet package, or like you can pip install the transformer Python package, and via that you can download the model and you can work on it locally. Locally, you can actually run the models. They're lightweight and they will run. But again, like suppose you want to use it from the API, so it's easier one, right? Nowadays, it's all about PaaS. Okay, it's like normally when we go to the Azure OpenAI, we just grab the URL, the tokens, and we start using it. So with that kind of flexibility, so like Normally, I feel that Hugging Face inference APIs are a great tool. I need not download it. I can directly infer it. But to infer that, what you need to do is maybe for I'll just tell you for Meta Llama. Okay, maybe I can search one of the models. You need to agree to the license and provide some of the informations out here. Okay, it's very easy. You just go to the models. Okay, you go to the models area, search Metalama or any of the models you use, and you agree to the licenses, provide the necessary informations and submit it. And once you have submitted it, so they normally take half a day to approve it. Once they have approved it, you can start using their model. But there is one more thing you need to do. There is something called as access token. Okay. So I have, for today's application, I have already created this access token. You need to create a new token out here, copy the token, keep it with you and use it. Okay. And also the permission, what kind of permission you need. Definitely I don't need a write permission, but I have, while creating it, I have done that. So and how to build intelligent apps using Hugging Face is you need to choose the model first, the variant of Llama. Okay, then connect via API or SDK. As I explained you, either you can download the model and run it locally, or do it through inference in API. Then you can integrate your logic and you can get ahead. But the primary feature is choose the Llama variant, on the UI of Hugging Face, agree to the license, and once you've agreed to the license, wait for them to approve. That is the most crucial stage, or else these models won't run. And then go ahead and you create your key. Okay, the key that you will be using it. Okay. So with this theoretical and some of practical demos, like few of the demos on Hugging Face. Now let's move to a bit complex part and the most interesting part of this session, where we'll build a Python Flask application, then Llama inferencing through Hugging Face API. We are going to take the API route. I'm not going to download any model to run it locally on my laptop, and then we will deploy it to Azure. Okay. So with this, let me go ahead. Are there any queries out? Let me just check. Okay. I have opened my VS Code, and definitely now what I'm going to do is I won't demonstrate anything like a usual developer, like normally like we used to develop all these days. So, but again, we will work intelligently with GitHub Copilot. Trust me, I'm not I'm not lying. It's a fact that this entire application I have built using vibe coding intentionally to demonstrate you, and I'll show you the prompts that I've given to build this application. You can see here actually, it's not this entire application has been vibe coded. Okay, see, I have I used to give. Okay, wait. Do a redeployment to Azure, or I can't show you the history, but this entire application is vibe coded. Okay, and now also I'll run it through vibe coding. So, but before I run it, so let me explain you a few things. This file diet plan generated.py is the one that actually does the inference. Okay. So if you see maybe I can ask, let me do this way. Like instead of me explaining you everything line by line, let the GitHub Copilot explain it. Okay. Now it will go through each of the files and it will tell me. And this entire application, I have built it in, say, a record 3 to 4 hours. That too also I used to take breaks and all. Like it's all through. I'm not a Python expert, but still I was able to build this Python program. Okay, let it generate the descriptions. Okay, see. Okay, now let me walk you through. I could have put all this in slides, but I just wanted to demo you and show you that the power of Gen AI that we have. So overall, this is the architecture, okay, of this entire application. User gives an input to the Flask app. Flask is nothing but it's a package. There are two packages that I've used here. One is Flask and another is VENV. Okay, VENV is used for virtual environment creation, and Flask app is something that helps in building Python applications, web applications. Something that you like. Suppose you want to build a website using Python, then you can use Flask app. You can also use Django for that, but Flask is simpler and easier. Like if you are a starter, you're starting on Python applications, websites and all, then Flask app is the place to start. Okay. So what it does is it calls the diet plan generator. Okay. That is nothing but this diet plan generator.py. It calls this, and this diet plan generator calls the Hugging Face API. Okay, and this Hugging Face API, it runs this Llama model 3.23b instruct and processes the response and provides the formatted output. That is the whole flow. Python application calling the diet plan generator.py, and from the diet plan generator.py, your Llama is called. Llama model is called through Hugging Face API. Okay, this is the configuration for where the model is called, and you can find this in this wait where I've kept it, config.py. Okay, we'll have all the prompt templates and this model config out here. So this is the model config is written here. Okay, then there is some description about model characteristics about the Llama that I'm not going to get into this. Then we are following a dual API approach, but inference client is preferred for Llama. When I said direct REST API fallback, so this is, but again, like this is preferred for Llama. So there is two APIs that are exposed. So one is like using the you understand, right? We have an SDK way of doing the things. If the SDK internally, they call the REST APIs. If SDKs don't work, we do a fallback to the REST API. So that is what it is done here. Then the prompt engineering. Before I get into this, I'll just speak something about prompt engineering. I forgot when I gave the introduction, I had that in mind. So prompt engineering is the core to any generative AI application. Either you can do a single shot prompting where you write your prompt, say that maybe a query like what is the weather in Singapore today, what is the weather in Hong Kong today, or rather you can say something like few shot prompting where you can give examples what is the maybe something like what is the weather today at Singapore, give me the response in this format example. Then in the example you can say that it was sunny in day, it was it was raining in afternoon, and it was again sunny towards evening, and night was moderately chilled. So then the response will come that way. In the same way, we have done a prompting here. So, and the prompt is, and also there can be a chain of prompts where you can give prompts like you ask something to the GenAI, it gives you a response. Based on that, you again ask. Then, when you have a complex task, you break down your entire task into multiple prompts and get it done. Okay, so here actually, like if you see here, so this is the prompt I'm building. So create a daily quiz and diet plan for age, weight, BMI, and cuisine. Okay, then like then some formatting has happened so that Llama can explain. Okay, Llama can understand. Post that uh, um, BMI based personalizations, how we are categorizing the like a person based on the BMI value. Then there is a message parsing algorithm where whatever response where actually we are converting the Llama prompts, the prompts that are going to give the chat messages into Llama tokens. Then there is a retry and handling error mechanism. Then we do some content filtering activities. Like this is for the fallback actually. But again, these are something if the model is down, then like for the fallback, all these will run where the model will try to give you a standard response. Instead of giving an error, it should give some standard response. So this is what it is written out here. Now now let me move to this is the entire algorithm flow. I'm not getting deep into this. I'll give you the GitHub link, you can actually explore that. Okay, so but you can see the entire explanation is um, generated by the AI. I've also generated beforehand to save some time to wait one moment. Go to that prompt. Okay, so I have given already a prompt where can you explain me the Flask application? Okay, definitely that Flask application is calling this diet plan generator app. Okay, so you can see what it says. Like it has also very beautifully explained me the Flask application also. So the application structure, the templates. These are the templates. Normally, like when you build any website, we build the templates like index, result. So where that we use to embed the data. Then the user profile is kept here. Then diet plan generator PY, where actually the AI integration happens, the crux of everything, and the configuration settings are kept here. Okay, so then here we are initializing the Flask application. Then you see those forms are created here. So age, weight, height, nationality, food habit, diseases, API token. So all these things are we put it here. You'll see that when I run this, you will find all these fields. Okay, then we have also done some form validations, and these are the routes that are defined. I'll show you. I'll take you to the Flask application. App.py. Okay, so you'll find all those. See, this is what this is the UI. This is the UI that has been built with all validations and all. Okay, and this is the routes. Now normally we write, if you have worked on web API, you will understand this. So when we say that ABC slash like even in Angular also, like normally in the front end applications also, we have these routes. Maybe ABC slash index, then it will take me to the index page. So we have defined those routes. You can see a route with generate. If it goes to the generate page, then it will generate a diet plan for me. So all these routes are defined in this app.py. And you can see the model also has explained me all these things. Okay, then I have also generated the deployment to Azure. Okay, so how the Azure deployment works, I'll take you there. So can you explain me the Azure web app deployment process? So you can see it has very beautifully summarized the deployment steps. Okay, so it says that we have two GitHub repos. One is where that uh, where the actually the this our um, code is checked in. So I will share this GitHub repo to you guys. And another is like that is used for hosting. If you see this scm.azurewebsite.net, this is nothing but your Azure website, or if you are aware of Azure web app, it is the kudu the kudu URL basically. Okay. So this kudu from the kudu URL, you can actually, like when you're deploying a Python application, you can actually use this SCM Azure websites as there is a Git by default that comes with your Azure web app that can be actually used to, like there you can actually push your packages to the kudu Git of your Azure web app, and there it will get deployed. Okay, that this is what it is mentioned here. So Azure Git is the direct Git deployment of kudu. So when you put your packages there, your application will start running. Then you have the source code repo. This is a source code repository that I'll be sharing with you guys so that you can take a look at it. Then these are the required files, it says. Then this is how your Azure will start up, the startup.py code for the startup.py. Then the code change is made and it is committed to both the places. One is your the source code repo in GitHub, and another is to, it is also pushed to the GitHub, the Git repo on the Azure web app through the kudu URL. So this is the code for that. Okay, then this actually triggers the Azure deployment. Okay, then uh, then this is the build build Azure build process that gets invoked in Azure, and these are the build steps that are listed. Maybe you can go through it. I'm just keeping them with interest of time. Then environment variables and everything is documented here. So now it's already I've already pushed the packages to Azure web app. So, but again, like I'll just show you. Maybe like what I'll do is let me first run this application locally. I will say run the application. Okay. Now you see the GitHub Copilot, which has helped me to generate all. Okay, I'll just to allow. Okay, the application has started. Let me just run it locally. Okay, so maybe I'll give my age. I'll just spoof my age. I don't want to reveal it. I'll just say like say 43. I'll just give my weight say 90. Then height say 72. Then I am an Indian. I eat both veg and non-veg. I'll select both, or let me be vegetarian today, even if I love eating non-veg. Obesity, some of the criteria. I'm just typing it. It's not my health condition. Just for demo purpose, I'm just typing it. And let me generate the diet plan. Okay, so this is my personalized diet plan. Like my age is 43, 90, 72. So this BMI calculations, I'm marked as overweight thanks to it. And then this is the meal plan that it has generated. Okay, now let me do one thing. Now let me just type in something like 43. My weight is 90. Height is 72. Then now let me say that I'm an Italian. Or let's have some fun. I'll call myself Japanese. Okay. So, and a vegetarian. Let's see what it does. I'm here actually, I'm just testing the Llama model, what it generates. I'm also curious to know. Okay. So, see, it gave me some nice Japanese foods. Huh? Like the model has generated all these things. Okay. Now, let me do one thing. I'll go back. I'll just stop this application running here. I will say like, can you redeploy? I have already deployed. That's why I'm giving this prompt, the application to Azure. Anjani sir, do I have another 5 minutes more, 5 or 10 minutes more to spend, or I have a hard stop at 10?
Actually, it was meant for half an hour, but anyways, you can
Okay.
spend five
Sorry.
minutes. No issues. You
Okay.
can spend 5 minutes more. Um,
Okay.
but this is
I'll wind
great.
up.
So yeah,
Okay.
we also have implemented Llama,
Okay.
and there are a lot of use that we are doing it.
Okay.
Same platform, Fifth yeah.
Oh, cool.
Definitely yes. It's doing
Nice
great.
to nice that
Yeah.
then we are in sync. My session is in sync with you
Yes.
guys.
Yes. Yes.
Okay. Well, first, I'm already done. I just need to do this deployment. Then I'll show the Azure part. Uh, so actually, I just wanted to give a feel of how this
Yes. Yes. This is
the new
fantastic.
age developers should work.
Yeah, so many people are from my team also, and
Okay.
so not all are from the same domain.
Okay.
So this would have been a great session for them, I think.
Okay. Nice to learn. Okay. Okay. Now I am committing Git so that now here actually when I do this, it will get pushed to SCM like Kudu, the Git which sits in the Kudu of Azure web app. While it's completing the deployment, I'll just show you a few more things. All these documents that you see, read.md and all, it's all I have not coded anything. Like it's all I have generated it. But again, when you're generating the code, one piece of advice: peer review them. If don't do a vibe code blindly. Peer review them. The reason being, many times like all these are open models. If you're having your own instance of GitHub Copilot, then a separate story. You train your own model, so it will pick up from your organization code. But again, like if you're working in an organization, you have multiple customers with you, so each of these customers again can get into a clash. Like the model will generate customer A's code in customer B's application. Okay, so just peer review them and make sure that you are not leaking any customer information. So you're not violating any licensing agreements and all when you're doing this. So that is one of the most important features that you need to take care of. Okay, I think the deployment is complete. So it's just summarizing the conversation history. Then I will open the website and show it to you. Okay, it's taking a while. Okay, thank you. Now it has opened the application as well. Everything what it has done, it has summarized. You can go ahead, check all of this and also review the code. So what I'll do is I'll say open the application running on Azure, just from here. So it will open it for you. See, I'll just open it outside so that one moment, where it opened. Okay. Okay. So now again, like I've already demoed you this application, so you should be able to do it. So with this background, yeah, sorry. I have come to the end of my presentation. So apologies, my bad. I thought it's a 1 hour session, so like I brought in so many contents in.
Yes,
So
really nice. Especially the way you got the code checked into Azure and everything through GitHub Copilot was fantastic, and I think many people would love it.
yeah. Open to questions if there are any. Now
Yeah, any question, please, raise your hand or just put in the chat. And there is a session. Um, Team, can you send the link for certification?
And also, this session is recorded, right? So we will all get the link for the session.
Yes, and there's a link for certification also, where you can take the quick quiz, and then there are some goodies, which we don't see a link here actually. Um, it doesn't have a link actually that you have sent.
Okay.
Subscription. Yeah, there is a question like on subscription. So you can create a free subscription, but again, like if you want to use it in a professional community, or rather you want to use it for professional development purpose, definitely you can refer to this pricing model. This is a community version I'm running at, so you can see the pricing out here. But I'm running it from a community perspective. It's not whatever application I've hosted here. I have done it just for this session, and I'll be bringing down the web app. I'm not monetizing this application.
Yeah, and the second thing is you can also download, the way Abhishek said, you can download Llama to your local server if it has that capacity, and then you can set up your APIs to get it connected to anywhere you love. Maybe we'll have to write couple of layer of wrappers on different technologies, whatever the technology your team prefers, maybe Golang, .NET, Java, whatever, to utilize it in a real world scenario. But yeah, Hugging Face is great if you just need to test and start with it. It's a very low cost.
Maybe I will propose one more session with Anjani sir for this how to run the transformers and the transformer package and get to run those packages, the same application locally.
Yeah, definitely much needed. Okay, so let's get back to the team here.
Thank you so much, Dr. Abhishek Mishra. A wonderful session, and big thanks to my audience who have connected with us. I hope this session is a very productive and informative to all of you. Keep learning, keep growing, and stay connected with 5th IR community upcoming event. Thank you.